So, I'm happy to see you all here. I warmly welcome everyone to this event. Soil brings us together, and we are connected to the soil with various ways. I want also welcome people who have joined us via online. There are people who we have worked with in northern Finland. There are teachers, some students, people from Lapland University. Then there are people from France, some people from Michel Devignier's office, and also some fermented experts. You're very welcome. And from Britain, from South Devons, we have David O'Carroll joining us, pioneer of Korean natural farming. And also some people from Iceland, Norway, and Japan. So you are all, and from Finland, you are all welcome. A Part We Shall Perish team wants to thank, of course, Mai and Tur Nesling Foundation for supporting us for 2 years. And also Lapland University, Arts Promotion Center Finland, and Cité Internationale des Arts for supporting our work in Paris. I tell a few words about our multidisciplinary project, A Part We Shall Perish. It is a project to explore different ways to connect with ourselves, others, and planet. We do that through community-based, inclusive activities and by creating moments for different actors to meet. We work to recognize and protect soil diversity and find concrete ways to do that. Now I want to introduce one of our team members here, Sari Stark, plant ecologist from Lapland University. You are specialized to impacts of climate change to vulnerable Arctic soil. With Sari, I have taken local young people to mines in northern Finland, students from junior high school and college from Rovaniemi and Kemijärvi. Here is one picture from there. We explored the site, these mines, with a multisensory way, and they mimicked scientific research that our project has been doing there. The idea was to open to students how scientific knowledge is produced. And also this holistic way of perceiving the field and subject and so on, not just like a cold science, but it is used with multisensory way. So in this, our project, we have done scientific research that reveals dynamics and complexity of soil, and that would tell us something about the healing processes, fixing processes that are happening in the soils of forests. And we choose the places and forests that are in different stages of this balancing process. So in our research design, we had 3 different sites. This is the first one. First is unrestored iron mine, tailings field, which has been left like this since mid-70s. It's a special site because their soil pH is around 8, when usually it's a 4. So the next reference site is commercial forest next to the mine. And the third one is a rare, old, protected Matovaara forest, also nearby. So, and from these soils, we were researching the activities of microbiomes and many other things, but also to get the feeling what is the process of fixing in a forest like. After being in the field, students continued doing research in Arctic Center Laboratory in Rovaniemi. With this concept of laboratory days, our project created new cooperation between local schools and research institutes, which has continued nowadays too. And this spring we are going to Polydenkevitsa multi-metal mine, where is nickel, cobalt, platinum, gold and palladium digged out with the students. There we get to know scientific research done about restoring process. Altogether, it's something about over 100 students. And there also we think about what we feel and what we see and reflect that. Then we have worked also in France, in Paris, where everything actually started 2021. Our whole project was inspired by a large greening program of City of Paris. And on the other hand, our interests to regenerative cultivating methods. We have explored in Paris microforest, Miyawaki forest, green networks, white tunnels, black corridors, as well as grassroots activism, social-related ecological activism, and vital contemporary ecological philosophy. This place is from Plastic Catalonia, and they are building microforest there, and they have produced a lot of data, how much it will affect by how much it will lower the temperature in this area, and also wind tunnels and this heat island effect. Because in Paris it is over 42 degrees plus the general temperature during the summertime. Yep.
People are saying on the Teams that the link in the email is for tomorrow's lecture. Should it be on Teams also?
Oh yes, it's more before. It's where you register. There is the link.
Okay, I will tell them.
Yeah. Where you register to this event, there you find it.
Okay.
Yeah.
There's many people on the wrong Teams.
Yeah, they need to read more carefully. Sorry to say. So I hope they get to us soon. So the drought and heat brought by climate change, as well as soil pollution and microbial poverty, calls for ways for revitalizing urban green areas. Our project studies the potential of microbial communities to enrich soil diversity and to support urban environments. We imagined Paris as it was time before agriculture. It was all forests, and some of those forests even still exist around Paris. We wanted to create a bridge between those still remaining forests and poor urban soils via microbial communities. In that process, we gather microbiomes from old growth forests and create new communities with regenerative cultivating methods that use fermentation. These transgenerational methods traditions can be found, for example, from Asia, where they are used in a large scale. In Paris, we had also some conversation events, workshops, and talks and open studios. But now we are here, gathered here to think about soil, to direct our empathy towards the soil. Everything is intertwined and interconnected. The concept of planetary health was introduced 2015. This multi- and interdisciplinary research paradigm has been defined as the health of human civilization and the natural systems on which it depends. In our project, we think soil as a living, active entity that has an equal capacity to change the world and people. So now I have an honor and a great pleasure to welcome our key speaker, Marc-André Selosse. He's a mycologist and evolutionary biologist from National Museum of Natural History, Paris. He will tell us the fundamental role of soil, open up, and how soil is related to human actions and climate change. Thank you. You're welcome very much.
Thank you a lot. So it's my honor to be there, and indeed I want first to thank you for coming, and also Nina for invitation and all this energy you were putting into launching this event and giving the opportunity to discuss with you a bit about soils. Yeah. My first point is that soils are often black or blackish, at least at the top. And this very first point is to remember you that there is what we call organic matter in soil. By organic matter, we mean these dead plants, dead microbes, dead everything that is giving a blackish color because there are so many molecules that virtually any wavelength of light can be absorbed. That's why, because of this chemical biodiversity, soil tend to be black, especially in the upper part where all the remains are. You may remember, for some of you, of your studies with humic acids, fulvic acids, or humin, you can trash all that. That's now old-fashioned, probably exactly as will be what I will tell you now. The current state of view we have from the organic matter in soil is made of at least 3 different things. One fraction is small pieces from the silt size, that is 20 to 50 micrometer in size. Small pieces, small remains of plants. And those remains of plants, they are rich in carbon, but poor in nitrogen. So virtually no one is aiming at eating that, because it's unbalanced food, not enough of nitrogen. So the species are stable because simply, if you eat them, you will not have enough of nitrogen. So it's not an equilibrated food for anyone in soil. small plant remains. The second organic matter in soil is microbial remains. So I will come to microbes later, but when they go to death, they are so small that their dead body is in cracks of stones or between leaflets of clay. The size of their dead body is rather the size of what we call clay, below 2 micrometers or even less. And they are very edible because they are rich in nitrogen. But since they are in cracks of rocks, since they are within clay leaflets, they are not accessible to enzymes. So they could be eaten because they are very calibrated food for microbes, for other microbes. But those dead bodies, they are stable because they are inaccessible. Exactly like a plate of chocolate, if you don't take out the aluminum and the papers around it, it's not edible. That's the story of this second fraction. There is a last fraction that was recently discovered. It doesn't mean that we have here the whole list. This other fraction is made of remains of fungi mixed with remains of plants, which cross-stabilize each other. It comes to something my research teams are working on, this association that you have between the roots of plants and some fungi from the soil. This association where the plant is giving carbon to the fungus and the fungus is harvesting mineral nutrients and water for the plant is called a mycorrhiza. And when it goes to death, you have a lot of chitin. Chitin is a kind of sugar polymer from the fungus. And also you have phenolics. That's why the roots is a bit brown here. Phenolics from the plant. And those phenolics chitin compounds, when it goes to death, they mix together into a mix that is very difficult to cut and eat. We don't know exactly what is the size of this fungal plant mix. But it's estimated that in boreal forest around here, for example, it's up to 70% of the organic matter of soil. So that's the newest view we have from why the soil is black. Silt-sized, nitrogen-poor plant remains, clay-sized, nitrogen-rich but hidden microbial remains, and something that is hard to define by size, this fungal remains mixed with phenolics, which is especially important in boreal ecosystems, a bit less in temperate ecosystems, and absolutely of no relevance in the tropics. Okay, and to be honest, this idea that the soil is black is not so clear worldwide. It's more clear toward the poles for several reasons. The content of organic matter in soil is maximal, green colors, is maximal toward the poles for several reasons. Let me just point 2 of them. First, it's very often cold, so this is lowering the composition process. So it's just a temperature effect. But there is another thing which I will not explain to you because it would go into much details, is that the more you go to the pole, the more the soil are on average acidic. And this is blocking the life of the microbes and so the recycling. We end up with this idea that the boreal soil, which cover, it's a bit disturbed here because of the projection, but the boreal soil, which are green, they cover 3% of the emerged lands. They store 3/4 of the whole carbon stored under the form of organic matter worldwide. 3% of the surface, 75% of the carbon stored in soils. That's enormous. That's the peatland, that's a bit the boreal forest, that's everything that is in those cold and soil acidic regions. Okay, that was my first point. There is organic matter in the soil. Now, it's not all the story of soil. Another thing is that in the soil, there is life. I a bit indeed already mentioned that, but I would like now to be more precise on what is life in soil. And I would like to stress that even if we think of worms, even if we think of plant roots, because plants are for 1/3 of their biomass underground, even if we think of that, it's not the main thing to think of when you think of life in soil. You have to think of microbes. And when you think of microbes, the first ones to consider are fungi. So there is a bit of French. It will happen from time to time that the translation is a bit unfinished. Fungi, you may know them from your kitchen or from your spending time in the forest as macroscopic. But that's only the reproducing structure. That's the structure from which, for example, from the gills here, they produce spores. That is, very small cells that are dispersed by wind. And when they land on the soil, they germinate into a microscopic filament, 10 micrometers across, which is, as you will see, their normal body, their daily body. Those filaments, everything is accelerated here, they grow from the tip, and not only they grow from the tip, but also they ramify, and this ramification, they sometimes network together, they bridge together, making a network that is called a mycelium. Mycelium can be big, it can cover square meters and square meters, but in every place, it's made of microscopic filaments, making the fungus daily, under its vegetative form, a microbe. And those microbes, they are present in soil. You can even sometimes see the whitish filaments when they are very abundant, but that's rather the exception than the rule. And you can smell it because those filaments, exactly as the reproducing structures that you can cook or harvest, when you crush them, they have this smell of octanol. Octanol, it's a bit of French here, but octanol is a molecule that is expelled by broken cells. And many soils, especially the boreal soils, when you sniff them, you don't see the fungi, but you can sniff them, you can smell them. Okay. In soil, you also have bacteria. Bacteria, remember us that there are many ways of being small. They are smaller than fungi, they are 10 times smaller, they are rather from the size of a micrometer. Even if sometimes they get formally bigger by living in chains or aggregating in groups, but they are 10 times smaller than the fungi. And actually, those filamentous bacteria that are called actinobacteria, of course, you will never see them. You can sometimes see mycelium, but never any bacteria. Still, again, you can smell them. The smell of soil is a molecule, geosmin, that is produced by actinobacteria, the filamentous bacteria. So when a soil has a smell of soil, it means it's rich in bacteria. That's rather the grassland or garden soil which have this smell. But sometimes you have the two smells. It gives you a good feeling of what is the dominant community, fungal, as in the boreal forest, or bacterial. Okay, so that's the other thing. And once again, and this is where we link the, I think, art and science, is that you need all your sense to get consciousness of the world. Because many microbes, you never see them, but still you can smell them. At least with some explanations, you can take awareness that they are there. Okay, and this, using the senses, it's not something science is training a lot. We need other disciplines to wake up our bodies to what's around us, by smell, by eyes, or by touching, anyway. Okay, last, amebas. Amebas are rather big, they can be bigger than the filaments of the fungus. Some are even visible by eye, the one that we call blobs, they are macroscopic. Those are big cells that are able to change their shape, to move, and encapsulate, phagocytate, as we say, bacteria on which they prey. By the way, here is a bacteria that will survive and that gives the size of the amoeba. It's rather big. They are very important bacterial grazers, and they regulate the bacterial population in a very important way. Okay, I don't mention the virus. There are probably tons, even more than bacteria or amoeba, but we have nothing to say. We don't even have the census. We don't know who is there for technical reasons. So we can't discuss nowadays, and it's the blind part of the picture. We can't say more about virus, but they are also numerous. But this is something science did not explore so much for technical reasons. Okay. Of course, there are also animals, and you see the columbola, pseudoscorpions here, this big predator, which has the front of a scorpion, but not the back of it. Nematodes, very small worms that are as big as filaments of fungi. Mites before, this is a myriapod, predator again, or worms, true worms that are visible by eyes, true insects like this coleopter. Okay. There is a lot of life, but once again, we should face that we first have microbes. When you take 1 gram of soil in your hand, it's thousands of species of bacteria. It's 1,000 species of fungi. We can know that because we are able now to extract DNA, and some are doing that routinely, as in my teams here. We extract DNA and we identify the species by way of the DNA that is present. We also have hundreds of species of amoebas. But now if you change the scale and go on the whole soil of an hectare of temperate region, you go to 5 tons of microbes, would be more in boreal forest, 5 tons of roots, fully the same, and 1.5 ton of animals would be less in boreal forest. But still, you go to the equivalent of 150 to 250, depends on their size, 150 to 250 lambs. That's an enormous matter, and you see that the animals are not so abundant here, but we have to think really of the microbes, and they are not abundant because they are eating on roots and on microbes. So, of course, there cannot be more animals than food for them. Soils encompass, depending on the study, from 1/4 to 2/3 of the living species on Earth. That's enormous. And now, in terms of biomass in our ecosystems, we have to think that they represent between the living biomass of soil, all those animals, microbes, and roots, represent 50 to 75% of the biomass of the ecosystem. So really, that's the fact that we are living in ecosystems that are mostly underground. Their diversity, a large part of the biomass, this is below ground, and it's largely microbial. Okay, so that's my second point. Soils are living. Okay, and now I would like to tell you a story. But before I tell this story, I just wanted to sum up the fact that soil is black with organic matter and life. There is a kind of balance between the two, because of course this organic matter is eaten by the life of soil, especially because all this life is making small or bigger holes, and those holes, they can be filled with air or water. This porous structure of soil, due to worms movement, amoeba movement, bacterial movement, growth and death of roots or filaments of fungi, they grow, they go to death, making a hole. This is making the soil porous. This is bringing water and air, and that's allowing some guys to develop. And not only they develop, but also they respire. That is, they use the oxygen from the atmosphere, and they are able to use, to make their energy, the organic matter. And they transform the organic matter into CO2. So in a way, the reason why organic matter is not permanently increasing is that at the same time, the life of soil is dissipating this organic matter and producing CO2. Going back to atmosphere, going back to photosynthesis. Okay? So it's a kind of balance between the black and the white horse, I would say. The black horse is this accumulation of organic matter, and the white horse is this life that is constantly, thanks to the oxygen provided by the porosity of the soil, making this organic matter into energy for itself and CO2 evolving in the atmosphere. And you know that because, you know, normally you don't have to take out when there is a soil, when there is a grass or a forest, you don't have to clean the leaves. Wherever you have trees in a garden, on an alley, or in a street, you have to clean the leaves because then you have no contact to soil. So this is this property of soil that is eating, incorporating and destroying slowly, more or less fast, the organic matter, okay? In nature, this is done by the life of soil, and this goes to full disparition of organic matter. This is an example of that. I shall come back to that later. This is a plant, okay, made of cotton. It's pure cellulose, and when you put it in soil, at some point, it starts to decay. I'll explain you why I show that later. Okay, and so once again, we have some soils in which the organic matter is accumulating because it's cold, for example, and because this life is limited. It's also limited in boreal ecosystems by the fact that there is often a lot of water in the soil, and this is limiting the oxygen evolution. Now, before I move on, I have to tell you, before I move to my third point, that we are lucky that we eat every day. And we eat things that are coming from the soil, be it vegetables, be it fruits, or be it animals that were grazing on soil. We eat soil, okay? And we found a way to eat more, and there is no more problem of hunger, at least in Europe, because we developed agriculture. But while developing agriculture, we made very bizarre things. And the things are at least bizarre from a climatic way. When we invented agriculture, we started to manipulate the climate. That's my third story, how agriculture is linked to climate. When you are plowing, when you make till, you oxygenate the soil because you are making big pores. So of course you kill animals, of course you kill fungi, but you don't kill the bacteria that are too small to even feel what's happening. Simply, you give them more oxygen. What do? They respire, especially because they are free of the competition of the fungi. They have more oxygen, and that's why the agricultural, the tilled fields are much less black than the non-tilled fields, the one where cattle are grazing or the forest soil, because there is a huge bacterial respiration. It is estimated that since we till, we make plowing, we've been producing CO2, we've been increasing the CO2 production from the soil by 300 gigatons of carbon. That's the fact proposed by Rudiman in his 2003 book, which I updated. And since 200 years, the fossil fuels, it's the production of 600 gigatons of carbon. So 1/3 of what we emitted it by plowing. Rudiman goes farther. He shows that when there was the big plague, of course there was less agriculture, so forests came back, the soil were again charged, stored organic carbon, and he's suggesting that the plague we had in the medieval time was explaining this cold climate we had between the 15th and the 19th century in Europe, simply because then we stored again carbon in the soil, so less CO2 in the atmosphere. His data are based on the fact that due to the cyclic astronomic position of the Earth, we have since 2 million of years regular glaciation that are predicted by astronomic cycle, the Milankovitch cycle. So you can say which trend is expected in CO2 in the atmosphere, because when you enter a glaciation. The astronomic design makes the Earth receiving less light. CO2 is dropping for a reason I will not explain here because it's a bit complex, but CO2 is just a kind of chain of transmitter of this factor. And since CO2 goes down due to astronomic reasons, then you enter a glaciation, or at least a freezing. And this, the expected trend we had, was followed at the beginning, and around 8,000 years ago, the observed CO2 stayed unusually and unexpectedly high. There was no higher CO2 in the atmosphere. We simply compensated a lowering of CO2 expected due to Milankovitch cycles. And this stabilized the climate, indeed. It was not disturbing the climate, it was just stabilizing it, making the Holocene, as I learned in my studies, the longest period of stable climate since 2 million years. We stabilized the climate. That's it. Plowing is producing CO2 and lowering the organic matter content of soil. If you look at the organic content of soils in France, you can see where agriculture is done. Aquitanian Basin, but not the forest of the land. Paris Basin, but not the forest of Chantilly or the forest of Fontainebleau where you were. You can see the forest on the map very clearly. You can see that, and you can even evaluate that in Europe, the soils, they lost half of their organic matter since the 50s of the last century. It's a dropping that goes very fast due to plowing, okay? So that's making glasshouse effect. But that's not all. We are also watering the plants. And wherever we water them a lot, the soil becomes anoxic. So you would tell me it's good for the organic matter because there's no more respiration with oxygen. Yes, but there are bacteria that respire without oxygen. They are less efficient, so the soils are very often rich in organic matter, but there is still a respiration that is not using O2 and producing CO2, but using iron, oxidized iron, and producing reduced iron, using sulfate and producing hydrogen sulfur, or using CO2, producing methane. That's what's happening in the methane producing units. Some also are using nitrates to produce this kind of gas here, the protoxide, the nitrogen protoxide. And all those gases, they have a strong impact on the climate. There's alternative respiration, those two ones, they produce a gas which is 25 times more efficient than CO2, or 235 more efficient than CO2. So in soil rich in water, you have much more glasshouse effect produced by way of methane and nitrogen protoxide. And indeed, normally when you enter a colder climate due to the Milankovitch cycle, CH4, methane, is going down. And compared to the expected trend, at the time of 5,000 years ago, we started to have increase in methane compared to what is expected, but more or less a stabilization, let's say. That's exactly the time where this started. So that's also the Rudiment hypothesis. And finally, nowadays, since we put the nitrogen under the form of nitrate in fields which have water or which are even watered, we end up by producing a lot of protoxide. This nitrogen protoxide, you have here the map of the production, and you see again for France where is the agriculture. It's there, it's there, it's there, it's there, it's there along the Rhine River, along the Saône and the Rhone River, in Limagne. But not, of course, here, because here you have very dry soils, so the respiration is made with oxygen. But wherever there is a bit of water, you emit this gas, and your agriculture is producing worldwide 80% of all the production of nitrogen protoxide, because it's not produced by industry. 80% is produced by the way we have wet soils and put nitrate. So 80% of what we produce. Okay, so you see here we come to a drama that is the way we made agriculture was interacting with the balance of storing organic matter versus using it, and we made an agriculture that is one of the factors by which we produce glasshouse effect. And it's a drama, I insist on that, because it's an example of how ignoring things or not knowing the mechanism of the world we are living in is just doing a catastrophe where should be a solution. I have been showing you that soils are black. I've been showing you that soils are alive. I showed you that the way we treat them is interfering with this process by destoring carbon. I will now show you that there is a solution. I'm very proud of introducing that because what I will show you is a French initiative, by the way. But, you know, it's just a logic. That this 4 per mile initiative, which was funded by a French Minister of Agriculture, Stéphane Le Foll, and they funded during the COP in Paris. There are a lot to see on the internet on that. The idea is a simple calculation. When you put organic matter in soil, it will be respired, but later. So for now, it's carbon that is in the soil. If you every year increase the soil content all over the earth, okay, by 0.4%, that is 4 per mile, you offset the production of glasshouse effect of humanity on that year. This is the reason for the name. But it's not to mean that you can do it. Because, for example, if the soil is very porous, like on sand, you can put organic matter, it's immediately respired. So some soil, you can't improve their content in organic matter. It's like, I don't know, 10% of the soil. Second, it's not possible to do it worldwide. There are large places where there is no human to put organic matter. And even third, we don't have enough of organic matter to do that everywhere, okay? So it doesn't mean that we will solve the problem like that. It means that this calculation shows that we have here a tool that is of relevant size to be among the tools we could use to cancel the emission of CO2. Storing carbon, not by planting forest, but just by putting it in the soil. I shall come back on that. What do we put in soil? I'll come back on that immediately, but first let me tell you something. This is a way to store what we emitted already. It's not a reason to go on with fucking rubbish like emitting glasshouse effect gases. We have to stop emissions, okay? That's not a solution to go on with the rubbish. But it's a way to absorb what we emitted already, which we have to do, because the delay between what you put in the atmosphere and the temperature you reach is from 10 to 50 years. So what the climate we have now is what we've been emitting, let's say, 20, 30 years ago. Fuck, if you have kids, you don't want to listen to that. You want to stop it. So let's forget that we have to stop it, and let's think of how we can compensate what we did wrong. So that's one of the tools. And here is the question: what to do to improve the soil organic content wherever the soil is sufficiently not porous to store for decades or centuries the carbon? First, not that. Not that, please. Especially because when you are preparing your soil for construction, you add often lime into it to destroy the organic matter. Okay? Quick lime, CaO, to kill the organic matter, to have a soil that is more stable. So it doesn't store anymore, but it distors at the time you are preparing the soil. So this is the thing not to do. Remember that in countries like France, it's 10% of the agricultural surface that was converted into cities or roads or trains or airport or technical platforms over the last 50 years. 10% over the last 50 years of soil in Europe are no more usable to store carbon. So we stop that. Of course, we stop that because we don't want to give too much of oxygen to soil. And we have some farmers, for technical reasons, that came to stop tilling like this one. Why? Because if you till a lot, you don't have organic matter, and organic matter is gluing the soil. In some regions of Europe, when it rains, the soil is just flowing with the water because it's not gluing anymore. So because of this erosion problem, they launched a non-till agriculture. The only problem is that when it comes to killing the herbs before sowing the next generation of seeds, you have to use herbicides. But despite you use herbicides, the soils, they have more life because plowing is more dangerous for soil life than glyphosate. It's fucking me because I don't like glyphosate. I know it's toxic. It's less toxic than plowing. And I come back to my pants, sorry. 2 months in a non-till soil with glyphosate. The addition of glyphosate was meant during the time this plant was in the soil. 2 months in the nearby field. You see the difference of life? That the guy doing this non-till agriculture, they use pants to show that there's cotton pants, okay, of course, not nylon ones, to show that their fields are more living. And the result is there. Look how it's nice. It's more blackish because there are pores. Because there's a lot of light, but there are small pores. It has nothing to do with plowing. The organic matter level is raising up. It stops erosion. It stores carbon. Especially because the guys of non-till agriculture, they don't leave their field free of vegetation after harvesting. They plant a lot of plants, fixing nitrogen, eating a lot the phosphorus and the nitrogen, sucking it out of the soil to impede the leaching by the water during the winter time. And finally, they destroy it on soil. So they bring the carbon of what was growing in winter. That's the other thing to stop. Useless winters. You grow things which are of poor interest to harvest, but that just bring organic matter to the field and you store 0.1 to 2 tons of carbon per hectare. In a time where you could not do anything else. And maybe you can ask the government for a bit of money for carbon storage. Okay? Cattle. Cattle, we know they are not good for, because they emit methane in their body. There is anoxic conditions without oxygen, where bacteria using CO2 and producing methane are living. But they can pay back because they produce this. And over Europe, what is the animal that is producing the most of this manure? Which animal is producing the most of such waste that we can put back to the field? Which animal? Yeah. Yeah. You kill my joke, but it's not that. It's not that. It's that. Really. And we have to think of putting that back to the field. Just one thing, by the way. By grazing those animals, they kill roots. Yeah, because when a plant is grazed, it kills the unnecessary roots. Then it regrows, make new roots. Grazed again, roots are killed. Those soils are highly storing root carbon. So that's the second way by which cattle, they pay back. Because they make fields in which there is a lot of carbon storing in soil. If you look at the French map of organic carbon in soil, you can see the zone where cattle are growing. It's like forest. Okay. Think of where you put your waste. That's, you know, we have a huge literature saying we should reconnect with nature, and we see people kissing trees, reconnecting to nature. Connecting yourself to nature is knowing where you poo and where you put your organic waste. That's the connection, because it's a solution even for climate. Okay, and to finish with, you see that there is a conflict between methanization, which is energy production based on biomass, and putting the biomass in soil. We have to think of that. This biomass, this methane production is good because the methane you will use will be burnt into CO2, but the CO2 that goes back to the atmosphere after using the methane is the CO2 that was just harvested by the plant for the photosynthesis of the organic matter that goes in the methane producing unit. So it's good for climate, but what is good for climate? Having a biomass that is transformed into CH4 and then to CO2 on the same year, or that goes to the soil and will be slowly returning to the atmosphere over the 10 to 100 next years, molecule by molecule, what is the best for the climate? It's not to put your biomass there. So I don't say that we need not to make methane. I think we should think of the balance between methane and giving carbon to the soil. Giving organic matter back to the soil and having itineraries, non-till, for example, and permanent cover is a way to use the soil as a solution, whereas the way we use them now is just making them a source of CO2. I will briefly finish by bad news, because that was a good news. But when I told you we have to stop the rubbish, I come to my fifth and last point. Soil is black, soil is alive. Agriculture is currently making glasshouse effect, but another agriculture could store carbon in the soil. 4 points. Fifth point, the bad news of the positive feedbacks. You know, in nature, it's not because you made 1% more something that the effect will be 1% more. It's non-linear. And sometimes you add a drop. And you know, it's like the last chocolate in this Monty Python film. You may know it? Take a last chocolate, explosion, because that's the chocolate too much. And it's not, it's 1% more chocolate, but it's 100% more effect. So it's funny on the Monty Python, but the first thing is that the melting of the permafrost, you know, the soils which are very rich in organic matter, but they are frozen. So the whole process of using that is locked. When they melt, not only there is a lot of organic matter, but this is filled with water. So it's methane producing. The melting of the whole permafrost is expected to raise the temperature between, depending on the models, 2 and 12 degrees. Okay? So that's one of the feedback that we don't like and that we don't want. In addition, there is a lot of methane produced deep in the soil and subsoil that is going through the rocks to the soil, and that is locked under the permafrost. So not only the permafrost, when it melts, is producing methane, but it's also containing frozen methane. And when this frozen methane is defreezing, it's going out sometime by making such things. Those are craters that you can see in Siberian regions where just it's the methane that is stored under the soil that is suddenly quite quickly melting. It cannot go out by simply conduction, by diffusion, and it goes like, you know, that's like fever buttons exploding on the permafrost. The other thing is the zombie fires. The zombie fires are fires that occur in the tundra and boreal zones where there is not even a forest. It's peat or peatland. And it's burning. You can see the burning zone here. It's burning when it's a nice weather. Then the winter comes. There is snow. It stops, but not fully. And when the weather comes back to a bit less wet, a bit more dry in the surface, no more snow, it's lightening from itself again because it's not fully extincted. Siberia is emitting between, those are called zombie fires because they are zombie during the winter. They look dead and they resuscitate in the nice season. Siberia is emitting carbon due to zombie fire at the same rate as anthropic emission in Belgium. That's a positive feedback. It means that you add up to the problem, and this is due to the fact that it's hot and drier during the summer. So the surface organic matter of the soil is burning, and it's not the vegetation, it's the surface vegetation. The last one is the most awful one. When you increase the temperature and the CO2 availability, the photosynthesis is going higher, and the soil receives more organic matter. The temperate, so not in your country, but more southward, the temperate forest of Europe, they store 1 to 3 per mile of carbon more each year because of the increase of photosynthesis due to the fact that there is more CO2 in the atmosphere and the temperature is higher. So the increase of photosynthesis is bringing more carbon to the soil. At first glance, it means that it's allowing the soil to store more. But the speed at which photosynthesis is increasing with temperature is lower than the speed at which a respiration of the soil is increasing with temperature. And we are at 2 degrees of global temperature from the point at which the two curves, the rise of photosynthesis with higher temperature and the rise of respiration with higher temperature, we are at 2 degrees of the point where they will cross. In 2 degrees, soil will store carbon more efficiently than they receive it. So I told you that soils are a solution if we speed up to stop the rubbish. And that's all for the soil and the climate. I thank you much for your attention.
So thank you, Marc-André, for your presentation. And then we will
It's a white one.
yeah, it's a white one. We continue by presenting other panelists. And first is Varpu Mikola, landscape architect.
Thank
Welcome.
you. Thank you. Okay, I brought some pictures. Okay, so I wanted to present myself with my partners, Mari, Anni and Riikka. We founded Nomaji Landscape Architects and nowadays we are a team of 20 landscape professionals. And our aim is to create habitats for everyone or living environments for everyone. Good living environments both for human and all creatures. And this picture, look at what is also in front and in behind. There's nice green vegetation. The photo is taken in November. And this is how the place was earlier. It is at the railway station. And this used to be a maintenance yard. And as you see, it's a landscape architect that is the best profession in the world because we can create paradises. And, but it's not easy. This is the technical part. And even though there is nice groundwater, but there is also a lot of restrictions and other designers, engineers who might be making decisions before us landscape architects. And that was also the case in this project that actually we had to build the soil and the areas for the planting completely new. We could not use the access to groundwater or any of the existing soil. But then again, it's possible to build it for new, and of course we are very eager to find out more about good solutions, better solutions, how to do this in an even better way to store more carbon and to really make it better in all the aspects. Thank you.
Slides are very speaking.
So, and then I welcome Marja Roslund with us. Aki Sinkkonen was not able to come, and we are really happy to have Marja, you with us. And you are from the same research group and a colleague of Aki Sinkkonen in Natural Resource Center Finland, Luke. Would you have the mic? Yeah, sorry.
Yeah, thank you. So my research is focused on planetary health concept that includes the well-being of the planet and how that is associated with the human health. And mostly we are doing this microbial scale research, how the urbanization and biodiversity loss and pollution, how they affect to the microbial communities in the environment, in the soils, and the human commensal microbiota, for example, on the skin and in the gut. And I wanted to say that we can think humans as holobions, that we are consisted of visible human part and then the billions of microbes. And it is estimated that like 99% of the genes in our body are like microbial genes and only 1% is human genes. So they are taking care of our metabolism and they regulate our immune system and neurodevelopment, and they can prevent pathogen growth and even cancer. And when we see changes in the urban environment mostly, that the soil is now sealed with the asphalt and other elements, there is disruptions in the microbial communities, also in the human body. The biodiversity loss is going around us, but also inside us. And mostly these disruptions, when they happened, we had this kind of bad health consequences. And one of our examples about our studies is the daycare study, where we rewilded these urban daycare yards with forest floor vegetation and transferable lawn, and children also received planting boxes. And after 1 month, we observed that the children's commensal microbiome was diversified, and it was associated with enhanced immune regulation. And now we have this new project. It's called Biodiversity Interventions for Wellbeing, and it means the well-being of the planet and also humans. And we are doing these biodiversity interventions at the public spaces and private yards and this kind of housing units for people with autism spectrum disorder and disabled people and elderly, because these people cannot walk long distances to reach the diverse nature. And we are trying to increase the awareness of people, so please do not take the leaf litter away from the yard and increase the dead food and branches. They are important for the biodiversity and planetary health. Thank you.
All right. Can you hear me? Okay, good. So, yeah, hello. My name is Visa Suonpää, and I'm a visual artist. And I have also background in cultural history and done a lot of permaculture, natural farming, that kind of stuff is varied. But it's always, every one of these parts are kind of coming into my practice as an artist in a way. And for the last 25 years, I've been a member of the IC98. That is one some people might know. It's an artist group, artist duo that has great influence onto my thinking and it has been a great learning process also. Like I would say, bringing poetics into the politics in a way. Yes, I have a couple of pictures actually. I want to show because they are because they in a way they tell what this "A Part We Shall Perish" is about and why it was initiated in the beginning. Here. So, this is, we met the Boy Scouts in the forest de Saint-Sermain in Lé. It's a surrounding forest, one of the last surrounding forests in close by Paris. And this is really funny picture because you might see there's a couple of tents. There's this Boy Scout tents, but there's another one to the left, and that is actually our tent, which is I would say like it was we had a vessel full of starch there, and it was we were feeding microorganisms. Actually, like we're talking more like indigenous microbes here. So the really like the special microbes which are you can find here. And why we actually selected this place is because of that huge peach tree there behind the boys, and that that's actually the one of the main characters here, and because that's we were looking in this forest the one of the tallest and the most vigorous tree, and that's what we found, and there we put our tent for the microbes, and I don't know exactly what happened, but the boys put a tent next to it, and they find it really funny also. They were very, very cheerful with it. So we were thinking that there's something special in this soil, because the tree itself is very, very healthy and vigorous. So there's very good microbes in the soil. So that's why we put our tent there. Yeah. So, but this is also like because I'm a cultural historist also in my background. So I'm interested also like this hidden histories as well, and I in a way this reminder me also the history that like an untold history, the hidden history, the secret histories, which Marc-André has actually written a great deal, but yes, so the microbes are like the true heroes, I would say, because the superheroes, we should look up to them, and they are the oldest. They are like they are true survivors. They have gone like through different climate changes already, and droughts and floods, they have this like knowledge to in a way to survive all this, and also there's a huge diversity also in the soils, and that is maybe the reason actually, and also this like a deep history or deep time or whatever. So yeah, so I was sometimes talking about marginal history as well, because in a way it's giving voice to someone who can't speak for themselves. So, but in a way it's not a good concept still, because these are not marginal. These are all over. These are we can't live without them. So they are not they should be in the center in a way in our understanding. And also they are histories. There's a history that is more like we are talking about co-evolution, mutuality, coexistence, collaboration, communities, diversity and dependency, and entanglement of lives. So this is a different history that we people tend to think we think as ourselves like a center characters, but we should think more like co-evolution, or like we are like a very young species actually. So we should listen to those who are more experienced. Well, okay, yeah. I'm taking the next picture here, and this is I'm sorry, I'm a little taking too much time, but this is a picture from Barcelona, and it's taken from Plaza de les Glorias Catalanes, and this is another city which has a huge greening program at the moment, and sort of a transition ecological transition program as well. So I took this photo because I was kind of seeing these as a characters, a new shift of of what is happening, and in a way we are inviting the nature into the city, I would say. So this is a shift which is happening, and it's forced to happen. It's necessity to happen, because as we know, the cities are getting really hot in south of Europe, but it's not there only, but it's going to happen here also in one point. So, well, yeah, this is also the picture of to me, remind that or possibility to imagine new futures also, and that it's happening. Well, it's happening in arts, it's happening in academics, in everywhere that we are thinking as nature and culture apart is going to be a history. And in this new situation and climate change, I think we are going to see new openness to different ways of knowing and approaches and the concepts. And I would like to bring up the Donna Haraway's nature culture and anthropologist Philip Descola's ideas of how the natural culture is mainly like Western concept, like this division, and it hasn't that long history actually, and the things which are seen as a part before can now be entangled. I think it is possible in this new situation. We are talking about climate change, but in a way, this is, in my perspective, this is a new possibility, and it's maybe not. I see hope in this, in a way. Well, yeah, I would say little about. In Finland, we have a concept, forest city. It's and a good example of that is Tapiola, which is already started building in the 40s. So, in a way, it could be an example and kind of revival of idea of building the cities. But Tapiola was built into the city was built into the forest. But now we have to do the opposite. We have to bring the forests into the cities. So that's I'm pretty sure that we're going to have to do, and that is exactly what is happening in this picture as well. Yeah, and I think we need to move on in a way to something which we call culture of care, and in short, it is to sustain the ones who sustain you. It is the title also this day also. Well,
Yes,
yeah.
thank you.
Thank you.
Thank you, Visa. So, like in Marc-André Selosse's, in your speech, but also like Varpu and Marja and Visa was talking when we were thinking, here are many layers at the same time, really like a global layer, almost like the time span is like millions and thousands of years, and the scale is huge, what is happening in the soils of our planet. But at the same time, there are these local solutions, and we are trying to do something about the local biodiversity and so on, that like Varpu as a landscape architect, and you are doing like city plans also in a bigger scale. So you are working with the local scale, and also Marja is also you in your research group, you are doing things that are planetary, and but the solutions are done in a local way. So I have first, if we start first a little bit thinking about the soil, I have a few questions about soil in general, and then we go more to the concrete ways of doing and examples what we could do. And of course here is all the time these two layers, this global and local, and what can we solve and what can we do and so on. I want to ask first from our panelists, could you share us some memory that you've been in contact with the soil?
Please start.
Ladies first.
Well, I can start. No problem. Well, I was thinking of like some general memories that I constantly do. I go picking mushrooms, I go walking on the peatland picking cloudberries, I weed lupins. But then actually I wanted to tell you about the memory from my childhood when I went to the forest with my father and we made a cultivation of morel mushrooms by digging a hole to the ground and putting large piles of newspaper to the ground and covered it, and then we got some nice morel mushrooms later.
Yeah. I also remember, like, when I was a child, it was so great. If we were with the scouts, we were in the forest and camping there, and you can just go out from the tent and walk on the soil like with bare foot, and the smell is like, I really love the smell. And I think that I didn't know back then, but now I know it's geosmin and the other thing. And human nose is like very sensitive to this geosmin. And I'm just wondering, is it something that that's why it's sensitive, because we have to smell it, so we are exposing the microbes, because these streptomyces that produce this geosmin smell, they also are in our gut and they can produce this kind of anti-cancer products there. And I'm just wondering.
So it would be important to go out and take your lungs full of microbes. And Visa?
Yes, yeah. Well, couple of memories I would think, but not maybe that much from my childhood, maybe from my adulthood. So when as I mentioned, I'm done a lot of, I always done gardening and I think all of who has been involved with garden or share the same experience that when you see the best of soil, which you know for sure, this is the good stuff. You you just feel the warmness and also you have to smell it. You have to take the deep breath to make sure this is good. And the second one is actually when we started this collecting these microbes, we were beginners at that point, and I think we still are, but when we bring one of the collection box into our house, which was covered, the rice was covered this white fluffy fungi, and I just I took it into our house and started to work with it, and then I realized that this is maybe too much now. The whole house. Well, first of all, I had there was trillions of little spores into my lungs, but after I took it out, but after a couple of days we still smell the scent of forest. It was quite astonishing. We wouldn't believe it that it's that strong. Yeah.
Is there some memory you want to share?
Yeah, it's my The only times where I do nothing, I'm building sandcastles or barrage in the wild. That's
Yes.
a hobby like any other. And when I was young, close to my parents' house in Brittany, I discovered along a small, very small river we had there, that there was a kind of clay. It was very soft and very easily to track. So I started to build a Roman temple, and then I discovered that it was very deep in clay, and I started to excavate that to make a gigantic barrage. It was 24 cubic meters. Okay, so I was digging and making, and the clay was blue. And so silky. So I was extracting those pieces, and with the hand I was doing this kind of it was so, and I had the smell on my fingers of a bit of H2S, but this little bit that is not ugly, and also this reduced iron smell, because that was filled with bacteria that was simply reducing iron and reducing sulfate, because it was clay full of water. So the color, it's the mineral we have in those clay soil is called fuggerite. It's a mineral that is named after a town in Brittany where it was described. And it makes the soil, which are full of water and rich in iron, blue, literally blue-gray. And then started the problems, because the clay was full of water. So after a few days, this wonderful gigantic barrage turned into cracking because it was simply drying. And I spent all my days filling the cracks with something that was again drying. And after 1 week, it turned brown-red, burk. Because then, of course, this reduced iron was used by bacteria that are oxidizing iron. It was literally like any metal, but even more than metal in the air, it was simply getting rotten by oxygen, and at the end it was not retaining water and not blue anymore, and not soft anymore because it was dry.
Now I think we go more into the urban soils, urban environments, and urban greening areas. I would like to ask first from Marc-André Selosse that how are the soils doing in the cities? I tend to think that they are poor, but how it is?
Briefly, not to be long. First, very often you've been taking out all the organic matter or the organic matter rich layer at the surface. So they don't have organic matter. Anyway, they are covered by concrete or anything that makes that the water doesn't go in, plus new organic matter from the trees and so on doesn't go in. That's why you take out the leaves. So it's poor in organic matter, poor in water. That's why it's very important when you want to have plants in the city to reopen also around for the soil to be able to soak water and give it back to the plant during the dry season. I saw that your pavement was made of separate pieces of stone, which is very good because you have a pavement, but the water is going between the cracks. So first thing is that no organic matter, no water, and often for breathing it would not be possible, but there's nothing to breathe anyway. There's no organic matter. So those are the main problems, and if we want plants, we have to restore them, we have to allow them to have access to the air so that they can take oxygen and water. But there is more. Often under our cities, the soil, they get richer in minerals, in heavy metals that we have on the roofs, for example. And the water, for example, Notre Dame is producing the rain flowing on Notre Dame, not currently because we have no roof, but as we used to have a roof. And soon again, it was allowing 20 kilograms of lead to go to everywhere per year. So, heavy metals, and second, oily compounds which are rich in aromatic compounds, rather toxic. When there is rain and you see the cars going in the street and all the small splashing droplets going under the car and going back to the soil, they are just washing all the fatty oil and so on from the engine and from under the car. 1 hectare of road is producing 10 liters of very toxic oily compounds each year in our cities. All that goes to the soil in a way. I don't know by which way, because it's often locked, but when you discover the soil that has been occupied by the city, there is heavy metals often and toxic oily compounds, so it's not always a good news for restoration.
That's true. And what about Varpu? What do you think? What would be the most or best practices the practices we should change, or some new ones to implement? Maybe what do you think?
Well, I think also that the drought is maybe the biggest problem that we have for the vegetation in the urban areas, that there simply is not enough moist in the soil, because all the water is just put to the sewers, and all those pollutants will end up either to the soil or to the sea. And another problem, of course, is the kind of short-term thinking that when we have nice vegetation areas, they are not preserved well enough. And if there is a need to make a tramway or something else, then they have to be cut down, and it is thought that it can always be replaced by new vegetation, but it's not, of course, it's not the same thing. It takes decades for vegetation to develop here, not to even mention the soil that might be original in that place. So I think those are the biggest problems from my aspect.
Yes, soil is often just changed and took another place, and like it's a mess that you don't think about like Visa was talking about the culture or history of it, and the connection that the fungi and microbes have already built in it and living in it. And
yes, exactly. And then new soil, engineered soil, of course, can always be brought in, but it is not the same thing at all. It's not the soil that has been formed to that place for a long time. So of course it is a nice possibility, and in the urban areas we have to use all the possibilities for city greenery. But quite often I'm sad to see that the very good chances are being missed for not seeing the real value that there would be.
can you give some example?
Well, as I mentioned, this tramway already, like we have a brand new tramway in Helsinki, and for some reason it is 20 meters wide or something, or even more, because all of the bicycle lanes have to be 5 meters wide, and it's very strict how it had to be made. So, of course, it's very important to have this public transportation, but somehow it's sad that everything has to be made with just one solution.
Yes. Do you think some implements that we should do in an urban environment from the health perspective, but also because they all go together?
Of course, like I said previously, and that leaf litter should be left, and dead wood and branches, and I think when I walk there, they already do this. I see that there was very huge dead wood left on the park, but of course there is so much asphalt, and that is not maybe enough. We have to be, and like the diversity should be kept somehow back. Like for example, these kind of plantation to the parks, they have always like there is some plants that are dominating, but it should be like the diversity also, and the microbial diversity should be taken into account, because if we compare like the urban soil microbiota and the rural microbiota, the diversity and richness is very low in urban environments. And when it's low, there is this kind of potential pathogens that might take the room because there is not enough competition, and that's not good.
Do you, Visa, have some ideas with what we should implement for this, or?
Well, yeah. Yes. As yeah, I think I agree that we need the diversity that's in plants and in soil microbes. It's a diversity which is key, I think, in everything. It makes resilient resilient environments or habitats, and so I think what we are doing, we try to bring this diversity into the urban environments, and I wondered always why we have to have like a really sterile. We're starting from a very sterile point. It's a ground stage in a way. When we start building green areas, we have a really sterile. It's maybe because of it's a business also. You have to have a certain kind of soil which is like not changing. It's there's no it's like the basic. But can we bring the diversity like a human intervention or a microbial intervention into the soils? That's I consider quite interesting topic.
Yes, and here in Finland, I think not so much in France, but in Finland we do not have that tolerance for dirty things or for different kind of things. We want everything so clean and similar, like you said, that the walking paths needs to be. And we don't. You have old houses and ruins and everything mixed in the cities in a way.
We also
tend to have so clean.
a more Latin. We have a more Latin way of seeing the dirt.
Yes.
We have dunks of dogs in the cities, and we just try to now stop that because tourists say it's not nice, but no one would care in France. And this tolerance makes us maybe more prone to contamination, maybe. We're not sure because the home environment is over clean.
Yeah.
And so we join, I think, the excess of hygiene that is common to all Occidental countries. Plus, due to this tolerance for waste, we, I think, leave more plastics and dirty things like that in the environment, which end up by coming back as microplastics or endocrine perturbators or mutagenic or carcinogenic compounds. So I'm not very sure we are saved by that. I think we are simply not saved, and we have additional problems.
Yeah.
So don't get dirty in this way. Get dirty in a more clever way. Shall I add that? I saw on your slide that you were rightly pointing to antibiotics, but something also that is probably more killing our microbiota because it's more daily is all the compounds we had as sweeteners, preservative compounds, antioxidant, emulsifiers. Some of our bacteria, they suffer also from that. Not all, but if you pile up all that, it's one of the reasons of killing our bacteria much more daily than with antibiotics.
Are we doing the balsamation to ourselves, everyday basics with those sugars and
so sweeteners, not sugars.
No.
Sugars, there is always someone to eat
sweeteners.
it. Not good for health, but it's not by way of microbiota. Sweeteners, emulsifiers, antioxidant, and the bactericide or bacteriostatic compounds. It's even true for the creams we put on the hands, which also contain that, except sweeteners.
I could now ask a question that is there some ways we could work with the soil microbes that we could take them account and work with them together? Does something come to your mind?
I don't know what did you mean, but one thing I could say is that those soils that they are selling for us, they are very often this peat, but nowadays they are more and more studying and developing new products that they are like peat-free, and we should like more use these composted soils and not like those peat-based.
Yeah, and they are adding like biochar or some mycorrhiza in it. But is it real? Does it do some? I know that the biochar is real and it's good to keep soil moisture, and also it's good home for microbes and so on.
Sometimes there is that if you add like some microbes like fungi or mycorrhiza or some bacteria to the soil, but then it doesn't survive because the others take it's their environment and they are used to it.
Yeah, there is no use from one microbe or a few microbes. It's always like a society or culture, and they just survive in that society, which is really like us, like we people also. We tend to survive only in society with other people. Is there some analogues with human societies and
it's hard
microbiomes?
It's hard to answer that, but I think that we have. I don't believe much in inoculations, to be honest, because as a microbiologist, I know that very often it's filled already with people, the community, so it's difficult to add one guy. And it's also difficult to add one guy that is the good guy of the situation. For example, if you think of mycorrhizal fungi, it's very difficult. Not every fungus is good for every plant. It's like in human beings. You don't need only one girl and one boy to make a couple. It's more subtle. And it's the same for symbiosis. So that's the first thing. The second thing is that after you inoculate anyway, you come back to the same point, which is the crucial one. What you do, how you wash yourself, how you eat, how you plow or not plow the soil, because when you plow, you destroy the mycorrhizal fungi, for example. What you do daily is the main question. You have to solve that before you think of inoculating, because if you don't have the behavior that is taking the most of the microbial communities, you won't find it. So you need really to understand how the community is working before and to find the ways to handle it in the best way. And possibly after you are sure you do the best, then you might, yes, inoculate. Why not? But those communities are very often like sleeping beauties. Everyone is there. It's just the number of individuals. Well, more or less, because for human microbiota, we could maybe discuss that. But everyone is there. Just sleeping beauty that you have to kiss, to wake them up. And so if you have the good behavior, it may be shorter with inoculation, but anyway, they are there. Just we have to wake them up. And I shall finish by saying that for the continuum between soil and our body and so on, Yes, let's touch the soil. Let's let our children touch the soil. But let's remember that we have to vaccinate. I know what is the situation in your country, but I know that my country is like Japan, on the top of the countries where people are against vaccination because you know there are cancers, multiple sclerosis, and blah 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 coming because of that. Fuck, there's nothing proven. Okay, so but they don't want to vaccinate, and if you have vaccination, then you can easily go to contaminating situations. That's what the concept of clean dirtiness I'm trying to push into my 2017 book. We have to be dirty in a clean way. And we are now too clean. It's not a reason to be too dirty. And vaccination is one of the tools to screen the good and the bad guys.
Now I would like to ask if there's questions from audience or from online, from people. I think we have just crashed something a little bit about this subject. Yes, please.
Yeah. Do you need a mic? I have a loud voice.
Yeah. Maybe for
I think that for online people, it's not loud enough.
You never know. Varpu, you said that in the urban setting we often miss good opportunities or don't see the value of existing nature or soil. So how do you think that we could change this and take it into account in urban planning and development?
Yeah, thank you. Great question. And also I was very negative, too negative maybe, because of course we also have better stormwater solutions coming up, and for example, city of Helsinki among many other municipalities have very good policies now improving the situation, but still in those policies there is the problem how to value enough the existing. And I think that there also the public, the citizens, they have a very big role, because it is something that is extremely important for them. So it's really good that people are speaking up and really giving their word for their close environment. And of course, I think that the people who work in the communities and in the landscape architects and architects, they are of course trying to do a good job. And sometimes there is no good possibility maybe to maintain the existing, but it would be really good to somehow maybe find ways also to count the euros, that what would be the long-term cost of either preserving or doing it the other way.
Is there other questions? Really good question, this one.
Hi, thanks for interesting discussion. When you mentioned Varpu policy, I think one of very conflicting policy here in Finland is this densification of city structure. And this is actually done by considering that it provides climate smart urban structure. But what is the downside of that is that really we are missing those still existing urban green spaces that can be very natural, but there is no strong kind of vote among, not necessarily among policymakers or decision makers, how to give a great value to those existing small, especially small scale urban nature we have still here.
Yeah, absolutely agree. And for example, here in Helsinki, I do understand that there are people moving in all the time, and it's really important to find also new areas where to build new apartments, and it would really need a drastic change how to find a solution to that.
I've been also sometimes thinking that we are blind. We have so much forest. We think we have so much green space somewhere there. So, and forest somewhere there a lot. Even we can think, is the forest any more forest if it's just a commercial production of the trees and so on? But it makes our blind in a way. When we were in France, you are so much more ahead with this discussion and thinking and criticizing, and you don't have any more these illusions of that there is a lot of nature and forest somewhere, because or maybe. But you had something to say, other also.
Okay, I have. It's okay, but yeah. Well, criticizing, it's cultural in France, so it's
Okay.
when you speak, you have to have at least address one critical point in what the other say. So we discuss it. Do we act on that? I'm not very sure. Maybe the discussion and the percentage of people that are aware of that is higher. But you know, I was visiting a bit, despite the weather was not okay for that. We were visiting a bit the city, and I saw this big esplanade in front of the main church. Yeah. Well, it's very mineral. Then we went through one street to the port, but this street where there is only the tram, it's still not made of concrete, whereas there is no more car going through. It could be greener, and it's large, so there is light enough for that. Then in front of the Chapel restaurant, it's ugly, dirty, water full of holes, substrate. There are many places where even in a dense place of the city like that, we can put the green. Because putting the green, it can be a 1 meter large zone of grass. Or the second thing is that densification, we have to think also of densification in the framework of the suburbs, where people are living alone, which is thermically, in terms of isolation, absolutely stupid. They are living alone in a small house in the middle of a garden, which is, we have really to think that it can be higher, and then more clustered, and then allowing more space for vegetation, but separate from denser building. I think it's the suburban model is really the killing model for that. And also in terms of energy, because you don't have this kind of gregarism that makes that the surface losing heat or cold in the summer is relatively smaller. Plus, since it's dispersed, it means more cars, so more oil to go home or to go work. So really we have to, and it's, I don't know for your country, but in France it's the dream to have a small house, a small cottage in the suburb, and it's not a dream because it's tremendously energetically expensive, and it's exactly what we don't need for our nature. We need common nature. We have to find a way that nature is something common between the buildings, a common space. And that means another way. It's less easy to say in a cold country than in a country like France, where even in the middle of the winter you can have social life in a green place. So I understand that, but on average in Europe we need also this idea that nature is a social place, not a private one. And then you can have high buildings and social place between the buildings. I don't know, because I'm not an urbanist or an architect, so maybe I'm wrong.
You're right.
Is there some more question? Yes, Sue.
Yes, hi. Thank you for the interesting conversation. My question is for Visa and maybe Nina as well. Could you say something about the role of art and artistic practice in this project? Like, is there something like, do you think there is something special potential there that art can do in this, like, in the project, like reconnecting with the soil and making people like think about and experience these things that, like, maybe that art can do that, like science, for example, cannot? Or
Well, I can start. I think the one thing is when we think this is as a profession, we are artists and have a artist point of view in things, and I think the artist, why the possibilities in art is maybe we don't have to restrict ourselves that much. We can be as emotional as we want. I think there's many things which, like comparing to like a science and researchers, I find it strange that like when you're talking about climate change or, for example, you in a way you always have to be sort of objective, not bring your personal area into the discussion. So the art and artists are not restricted in that way, and I think it is also the power which we need, that we have to talk from the emotions and keep the spiritual and philosophy and all these. This is not just like well, but you know, understand what I mean. So that's the first thing which comes into my mind, but if you want to continue.
Yeah, one thing that came to my mind in this project, and when I've been working with Sari, is that we wanted to create these spaces where we can have a positive and free space. And in north of Finland, where we have been, it's quite a hot potato, these mines. And to be able to go and visit in those mines and reflect what we feel and reflect the scientific knowledge and also the feelings and memories and the history and what the families are thinking and these kind of things. So it's, I think this kind of connection between people, there is in our time, there is need for these kind of places. And myself, I think my actions, they are like a form of activism. They are also a form of, I think these are like socio-ecological sculptures or something like that we are doing. And it's so nice to gather people together and think together and make something out of it. And I hope also that when you go home, you have took something out of this and maybe start a conversation with another people and thinking about the soil, for example. So this is just like dance we are doing together, in a way.
Well, yes. Yeah, I was thinking also one thing, which is like talking about the openness to, you maybe referred to before, like the different ways of knowing, and I think especially in art there's no hierarchy. There's no hierarchy that we can like it's like a knowledge which is hierarchical. It's not like a pyramid or anything like that. So it's certain freeness in art, which is also bringing together very surprising elements and finding new solutions in a way that maybe from like very much like we are not like in a certain discourse or anything like that. We are surfing between, I don't know. Yeah.
I think we are soon coming to the end of this evening, but I want to still, because often today I remember, Marc-André, that you have been speaking about this reorganizing science, because we have these pollution crises and climate change, these huge problems. But also when we were talking about this city planning and how we could improve and save some areas. I think the one way thing is that different specialists get together and work together, so and crossing borders and so on. So my last question is, what kind of collaborations would be necessary, and in what kind of collaborations you have worked in terms of?
I think everyone has his own idea on that, but I can see that scientists are not able to warn, and not only to warn about what is happening, even if they speak, I mean, it's not going into the minds, it's not changing the attitudes, the behaviors. And more concerningly, they are not able to convince that they also are having potential solutions. Potential solutions because, okay, we have some ideas on what we could do, how we could replace pesticides, how we can replace plowing. It will not be an easy way, but we have some ideas on how to do. And this positive side is even fully overlooked. So that scientists, they get this reputation of being like Cassandra, you know, this lady that was simply announcing catastrophes. And it means that to find the way to the brains of the citizen, to make this warning efficient, but also to make the possibility of solutions efficient, we are fully unable to do it as scientists, fully, and we need cooperation. And I often think that this is where we meet the function, one of the functions, I mean, it's not the function, but it's one of the functions of art, because with art we can maybe go more to people, or go to people, making them aware of the environment, of the living beings, of the microbes, in a way that is more speaking to them than even the best outreach specialized scientist is able to do. So to take into account what is around and to reconnect, I think we need art. But art is one of the things we could imagine, but we need help, because clearly, since decades, we are not able to speak to the society, and it's because there are things we don't know how to do, because there's a specialty for that. And to finish with, I think also we have to bring a view of the future, how it could be. We have to make clear what are the possible things in the future. And for this, again, we are not able as scientists to make it clear. We need people specialized in that. Artists may be among those people with utopia that they can generate or illustrate. I think that people specialized in advertising, you know, they are able to sell you a product to wash your toilets. So maybe they can sell you also another future, an alternative view of what could be a city. Okay, so we really need to cross the boundaries of the know-hows to explore the future together. And for now, everyone is exploring, putting his ideas and his know-how in front of the society to promote the future, but none of us is efficient, and business is going on as usual.
Yeah, very, very good points. And I completely agree with that. I try to come up with something else. Well, of course, Marja's research is something that I have been referring to many times, and it really has helped me in my work to get through with some ideas in the design that I would like to promote. And it's very important to have something strong, like a study that tells that this thing really is good. It is good for the daycare children. And it has somehow even gotten into a phenomenon in Finland, at least I would say, that now all the daycare managers, they know that Microbe is important for children. And I'm very happy, and I'm thanking you and all your colleagues that you have done such an important work. And of course it would be interesting to collaborate even more, and how can we really like take even more out of these ideas in the daycare yard design and design of any urban environments. And then again we come to the how to do it. We need some products in the building industry, in the green building industry, what kind of engineered soils we would be using, how can we get rid of the geofabrics that are containing plastic and all of that. So there would be so much to do, how to develop the industry into the better way. Then we come to the maintenance of green areas. We would really love to leave all the leaves in the parks and so on, but we have to somehow get the pressure, maybe with the help of press and social media and all the people who demand it. And finally we might see more wild parks and areas.
Yes, this idea not to touch, to leave things laissez-faire and so on, to tied up, and it would be great idea to sell. Do you have, Marja, some?
No, well, of course we have to cooperate with other scientists from different fields, like we are doing with medical scientists and architects and urban planners is very important, and artists, because they can really increase this awareness, because if you do very fancy things with the dead food, then it's more, people are accepting it more easily. And we have to also cooperate with ordinary people who live there, because if they are like, no, what are you doing, then it's going wrong.
So, well,
You can
go
go
ahead.
first, then I can go then. Yeah, of course.
Oh. What, do you want to ask me as well?
Yes, I can ask.
What was the question?
What was the question? But I think we were talking already, you and me, about artistic approach and how what is the role of art, and then I asked about their collaborations and so on. So let's let you.
Let's go on.
Yeah, thank you. This actually continues on the collaboration, so that's why I wanted to take the chance. And thank you for the event, actually, because we didn't know about this event until a couple of weeks ago. And when I say we, I talk of a collaboration where there is a research project and then Ympäristötiedon Foorumi, YHYS ry. And we have also now just recently got inspired about the soil. And we will kind of continue in your footsteps in a couple of weeks. We're going to have a policy dialogue in Tieteiden talo in Helsinki, 14th of May, where we will look into the building practices, design practices, maintenance practices for the living soil and the policies, politics around it. So please welcome in the morning of 14th May. And thank you, because this event has now laid the kind of a basics of the biological part of the thing, and also the experiential part. So we are doing this together. Thank you.
Yes, I have noticed your event, and I think it's really great. I could also Allergialiitto. They have time to time. They have seminars and webinars And if you want to go to see their latest webinar, it was 18th of April. And there is, for example, Tari Hahtela talking about planetary health. And also he referred to your researches, Marja. So that is telling about this, how we should have this evolutionary connection to the soils. And he tells like Alzheimer and this kind of research, that how Alzheimer, for example, is related to how our soils are covered, and also diabetes and asthma and allergies. So I want also to advertise that event. It's in YouTube.
Maybe just another.
Yeah. Yes.
Especially those who are very much interested to collaborate. Of course, we can't forget that also European Union is pushing a lot now. There's a soil mission, and related on that, there's a new calls opening this autumn, and especially we would like to see. I'm working in a Finnish Environment Institute, and now there are established national committee for soil health, and what we are still missing in Finland is these kind of living labs, and there's a good now push and willingness to start to build on this for urban agriculture, forestry, and there should be also artists and different kind of sectors and disciplines engaged. So please be contacting these people who have been here, and if you feel that you want to contribute.
So I think now is the time to close this evening, and undertone of our event, I think, has been going toward natural systems, building alliances and protecting planet, and doing cooperation. I have understood that all life depends on those maybe 10 to 15 centimeters layer top soil. In Arctic soil, it's even thinner, maybe the top soil, but all life depends on those 10 centimeters. And if we think that the forest produces 1 centimeter of that layer in 100 years, so 1 centimeter comes in 100 years. And if we should think about also rights of the soil, if we are just digging it, or mikä on kuoria, peeling the soil. So we are actually peeling the gold in a way. So we think that it's more valuable than gold, actually. I want to thank Monsieur Selosse, Varpu Mikola, Marja Roslund, and Visa Suonpää, behalf of the Apart We Shall Perish team. And of course everybody in the audience. Please spread the word about the soil as active living entity, the invisible that supports the visible.